All right, 9.7, law of sines and law of cosines. Starting off with 9.9, the law of sines. We can write it two different ways. The first way, we say sine of the angle A over the side length A, sine of B over the side length B, sine of C over the side length C. And the second way is just the reciprocal of that. Let's look at this in our picture here. A is an angle, and opposite of A is side A. And then that follows for B and for C. Now, there are some cases where the law of sines does not work. So a lot of the times you want to look at your answer and tell yourself, does that make sense? Right? If it gives you some acute angle and it's supposed to be an obtuse angle, well, that doesn't make sense. If your angles don't add up to be 180, that doesn't make sense. And if you get one of those cases where it doesn't make sense, then you're going to want to use the law of cosines. It almost always, actually, it always works. The law of cosines, I've always thought of that as the generalized Pythagorean theorem. Look at the bottom piece here. We start off with c squared equals a squared plus b squared. And that would be true for any right triangle, but we want it for just any triangle ever. So c squared equals a squared plus b squared minus 2ab cosine c. Now, what this always does is it's the side length squared, and whatever side length squared is alone on the equal side, its angle is in the cosine on the other side. And the other two variables are just the other side lengths. Now you could use this to find any of the side lengths that you chose, right? You just would have to plug in and solve it different directions. You could even use this to find the angle C by using the cosine inverse. And here I accidentally wrote that again. Number 29, we want to solve the triangle. And let me find a calculator. All right, I have found a calculator. Solving the triangle, it doesn't really matter which one we'll use. I'm going to use the law of sines just because we haven't done that one yet. So we have 17. 17 goes with sine of B. 40 goes with sine 119. And then, well, we don't have either C's, so I'm not even going to write that. We don't have the angle C or the side length C. So you can just pick and choose any of these two of the three of fractions here. This one we want to get solve for B, right? That's our variable. To solve for it, I'm going to have, well, sine B equals, what's that going to be? 17 sine 119 over 40. Whenever I take my inverse, I'm going to have B equals sine inverse 17 sine 119 over 40. And whenever I type that in, I will have sine inverse 17 sine 119. I got, what did I get? 21.8. So B is 21.8. And I want to look at that picture. Does that kind of make sense? And yeah, it kind of makes sense. To find this other angle, angle C, I'm going to take 180 minus 119 minus 21.8. And that gave me 39.2. Now, there's multiple ways we could go about finding the side C here. The way I'm going to do is I'm going to use the law of cosines here, because it would have C squared equals it, like all on its own. So I could say, well, C squared equals A squared, we'll say 17 squared plus 40 squared minus 2 times 17 times 40. Cosine of C's angle is 39.2. Now I'm going to type this all in my calculator in just one long string, and whenever I type it in, I'm going to type it in underneath a root to get rid of that square there. So I'm going to type in, starting off, square root of 17 squared plus 40 squared minus 2 times 17 times 40 cosine 39.2. And I got C equals 28.9. And there we are. We are all done. Number 30. We could start off right away by finding that other angle measure. So I'm going to take 180 minus 71 minus 40. And I got 69 for that. Oh, I don't know if I told you what our answers were for 29. I'm sorry. On tests, on quizzes, I think you should write down all of them in the picture. So I didn't even follow my own rule. C is 28.9. It told us to solve the triangle. To solve means to find all the missing angles and to find all the missing sides, right? So that's 3 and 3. So whenever we're done, we should have all 6 pieces of information drawn on our triangle. All right, back to number 30. All right, I have all of my angles. They're all acute angles. I have 2 sides missing. I'm going to use the law of sines. I'm going to write down all 3 fractions here. So I'm going to start off with A over sine of 69 equals B over sine 71 equals C. Oop, not C. Actually, no C. C is, what is C? C is 16 over sine 40. Now, I'm going to start off by looking at the first and the last fraction, right? I'm going to ignore that middle one, right? The first and the last fraction are equal to each other. So I could say, well, A equals 16 sine 69 over sine 40. And before I type that in, I'm going to go ahead and write that down for B as well. B, I'm looking at, oops, that's supposed to be a highlighter. This one and this one. To solve it, I would say, well, B equals 16 sine 71 over sine 40. Whenever I type these in, I have 16 sine 69 divided by sine 40. This is 23 point, let's say 2. So 23.2, I draw it in my picture. And then 16 sine 71 divided by sine 40 is 23.5. And there we are. Notice that these 2 side lengths are very similar in length, right? Their angles that they get opened up to were 71 and 69, which are very close angles, right? Remember, I don't know if you remember this, but if the angles are equal, then they have to open up to the equal side lengths. These are very close to being equal, so their side lengths have to be close to equal. So that's a good way to check yourself. If you're uncomfortable that those 2 decimals are similar, look at the angles. The angles are 71 and 69. Well, those are only 2 degrees apart, so it would make sense that those would be similar side lengths. I'm going to skip number 31, and we're going to go on to 32. 32, all of the angles are missing. All of the angles are missing. So I'm going to pick an angle here. I'll use B, and I'm going to use the law of cosines. So I know that, what is that? 34 squared equals 19 squared plus 38 squared minus 2 times 19 times 38 cosine B, right? I wanted to use that B in that formula there. Now in my calculator, I'm going to type in 34 squared minus, I'm going to take out the 19 squared, minus 38 squared, and I'm going to go ahead and press enter. This is negative 649 equals 2 times 19 times 38 cosine B. Now I'll go ahead and divide by, oop, that's a negative 2. Divide by negative 2, and then I'll go ahead and press enter, and then I'm going to press divided by 19, and I'll press enter, divided by 38, and I'll press enter. So now I have 0.4494 equals cosine B. I'm going to take the inverse of that, so I'm going to say cosine inverse, and since my calculator still has that whole decimal stored in it, I'm going to use it. So if you type in 0.4494 cosine inverse into your calculator, you might get a slightly different decimal than me because I use the full decimal. We got 63.2, we'll say 63.3. And that's how we got angle B. To find the other angles, we would need to just solve that again, all right? I'm not going to do the full solving, but I will write the equations down for you so that you could solve them on your own if you'd like. We'll do angle C next. Angle C, to find it, I would say, well, 38 squared equals 19 squared plus 34 squared minus 2 times 19 times 34 cosine C. And you'd have to solve that for angle C, and whatever you'd get there, you'd put that on your triangle. Now, after you have angle B and angle C, you could find angle A using the law of cosines, or you could just say, well, the angles all add up to be 180. I'll subtract this and get my angle A, okay? It's good to, after you do every piece of information, to kind of reevaluate what's the best way to do that. What's the best way to find the next piece of information? All right, so that's how you'd find angle C. I'm going to skip numbers 33 and 34, and I'm going to skip 35 too. You're welcome to ask me about those in class. I'd be happy to do them in class. But a lot of your homework is going to be very similar to, what is this, 29, 30, and 32. So there we are.